Hello students, welcome back. So we were discussing about the sample very low code simulation and the RTL schematic generation in the previous video. So continuing with the same example, in this video we are going to talk about how to run the behavioral simulation, how can we assign the values to the input signals, and how do we generate different test cases using the waveforms. So all of this again we are going to do using the Xilinx Vivado design suite, and let us get started using the same example. So students, this is what we had. We had generated the RTL schematic. Whenever you are done with the verification of schematic, please go to this elaborated design bar and close the schematic by clicking this. Okay, this is necessary. You should not keep a lot of things opened in your Vivado. It's already a very heavy software. Now, for the simulation, we will click on Run Simulation. Again, we will click the left click and click on Run Behavioral Simulation. Now, the software is preparing the simulation environment and it will show us all the options that we can use for generating the test cases and running the simulation. Again, it can take few seconds, so you have to be patient. And now this is loaded. So here I have my scope, that means which are the program that I am going to run the simulation on. So you should carefully select test 1. Then these are my inputs and this is my output. You should right click. Now we have to right click. Right click on A and then you can see that I have 3 options. Force constant can be added, force clock can be added, and the allocated signal can be removed. So when I select force constant, I have the options of selecting which type of number I want to assign. A is a single bit value, so it can be binary, hexadecimal, octal, anything, but it should be single bit. So either you say hexadecimal or binary, both are fine, and I say 1 and say OK. For B, I am selecting 0. This time I am taking hexadecimal. Let us see if it will give us any problem or not. And for C, I am selecting force constant as a binary number 1. On the top, we have the options for how much time we want to run the simulation. You can select the time here. Let us say we are going to run it for 100 nanoseconds. Okay. And then these are the 3 options. One is run all and one is run for the given time, which is 100 nanosecond. We click on this and the outputs are generated. So you can see here this A is 1, B is 0, AND of A and B will be 0, but 0 or with C the output will be 1. Now if I change C to 0, then I should expect the output to be 0, and that is what we got. Now what I am going to do, I am going to change B to 1, and now 1 and 1 should be 1, so I am expecting the output to be 1, and that is also fine. Now this is how we generate different cases and test them. You can do one more thing. Go here and maximize this, and then click on this zoom fit. Now you can see this was my first test case. Wherever you click, this bar will appear and corresponding values will be visible here. If I click here, this is before the simulation started. So there are no values, no valid values. This was my second case, and this is my third case. You can also zoom according to your convenience, zoom in or out according to your own convenience. And you can visualize all the test cases, cross-check everything, and then be satisfied as a designer that yes, my code is working. So students, that is an overview of the Xilinx Vivado design suite. Once you are done with the initial RTL schematic and simulation, then we go for the synthesis, implementation, and generating the bit stream. These things we will discuss in detail when we start talking about the FPGA implementations. So students, now that we know about Vivado and how to run some program in Vivado, we are going to explore one online Verilog simulator in the next video. We'll see that how an alternate solution can work for practicing Verilog coding. Keep learning. Thank you.